Oh, it didn't make the cool noise.
You don't hear my cool noise?
Uh-uh.
Hello and welcome to the Hackaday podcast. My name's Elliot Williams. I'm editor-in-chief of Hackaday.
And I'm Kristina, Panos, assignments editor at Hackaday.
This is episode 197. This week we'll be decoding VHS, engineering the TV Guardian, and getting code into your ESP32s.
Ba-dum-ts.
See, get it, getting? Get it, getting?
Yeah.
Man. Let's see, this week in the news, I wanted to talk about the Artemis I / Orion capsule landing. I guess it happened on Sunday, and by Monday, Tom Nardi had written up an article on it for Hackaday. I thought that was really great. Artemis I was a test run to get up around the moon and back to Earth. The things I thought that were most interesting about this was the science going on because, well, I mean, it was kind of a dry run. There were a bunch of neat CubeSats on board, and Tom's article goes into those. One of the coolest ones, which was going to be Japan's Omotenashi lander, was actually going to try to land on the moon. It was a tiny little lander, and that one did not respond, and they think it just didn't catch the sun with its solar panels, and so wasn't able to charge its batteries, and so who knows where it is. A couple of the neat ones did work, however, and actually just recently we got news that the Team Miles CubeSat, which is done by at least one reader of Hackaday because Don Smith keeps showing up in the comments giving us updates on their CubeSat. This is one where the experiment is to transmit radio signals back to the Earth using kind of citizen-grade radio technology and prove that it can be done. And they got a NASA Challenge grant to do this, and it looks like they heard back from it on December 9th, so actually a few days ago, and that is super good news. Because they have heard back from it, they can now get NASA's ground stations to start listening, and they'll definitely hear it, so that's good news. The other thing that I'm really interested to hear about, and we haven't gotten any news from NASA yet, is the dummies / mannequins they had on board. Then the really cool ones, to me anyway, were they had two also in the capsule, but further back, and one of them had a radiation protection suit on, and the other didn't. And both of them were like hyper-accurate female anatomy dummies because we've never done deep space radiation tests on women before. They've all been on men. And one of the goals of the Artemis mission is to land the first woman on the moon. And so these models are like super accurate to the extent that they've modeled, different tissues, and, they have emulation breasts and they have bones in them. And the question is, where does the radiation get stored in the human body? Because what matters isn't just the dose, it's kind of where you take it as well. And is this going to matter? Is this going to be different for women than it is for men? Nobody knows. They've never done the science before, and this is their chance to do it. So they're doing that, and one of them has the official radiation suit on, and the other doesn't. And so the question's going to be, how good is the official radiation suit?
Versus the birthday suit.
Yeah, right? And the other one's kind of in some kind of birthday suit. I think it's, nylon or something. It's pretty normal.
Oh, okay.
Anyway, I'm super stoked to hear how the science comes back from that, because certainly in the lunar environment, there's a lot more radiation than there is on the Earth and near the Earth, like at ISS. And then, if you're thinking about going to Mars, that's a lot more. And so it's interesting to start worrying about the human health of sending people up there as well, because, well, this isn't the 60s anymore. We know a little bit more about ionizing radiation, and we try to keep people from getting cancer from it.
This is a journey into sound.
What's that sound?
What's that sound?
What's That Sound is a Guess the Sound challenge, and last week we played a sound. We had 50 people write in, 29 of them got it right. Kristina, you cheated and listened to the sound last week, and then I screwed up and told you what it was.
But I had no idea.
But we can't play our normal game of like playing it on the air. So I'll play a short sample for the listeners at home. It's one of those industrial metal shredder machines, and in this case, it's taking on like a 50cc moped in the video I picked it out of. And so those terrifying crushing sounds are the sounds of like a Honda 50cc scooter meeting its final days.
Poor thing.
Yeah, have you seen those videos on YouTube?
No, that sounds fun.
What? There's a whole like mini genre of people taking videos of dumping random stuff into shredders.
Oh.
You've never watched these?
No.
Oh my God.
I've seen a bunch of the press, the channel with the big press.
Yeah, right? This is like that, but even more terrifying if you can imagine. You'll have to watch. They're really impressive.
Okay.
Apparently, our viewers knew what was going on here because the answers range from right to very right. There's 29 of them that are all like metal going into an industrial shredder. And, you know, I can't ask you to tell me what model the scooter is that's getting shredded, but that's exactly right. Although some of you tried to say anyway, metal shredding machine eating something for recycling, maybe some old home appliance or electronic device, you know? It counts as right anyway. Demanufacturing of waste electronics, like the awesome Franklin Miller Taskmaster TM4000 shredder in action. What? Yeah, a lot of you thought it was a hard disk shredder, which I guess, I mean, you could certainly throw a hard disk in there and it would certainly get shredded. Good wrong answers include, let's see, what did Tom say last week? Oh, Tom thought it was the Strand Beast. And I was like, what? This is much scarier than that.
So you admit that the Strand Beast is a little scary. I'm not alone.
They're just walking along on a beach all by themselves. Man, if I saw one coming at me.
Yes. Run into the ocean.
So yeah, let's draw a random number. Let's see, what am I doing? I am catting dev urandom, which is a Linux device that gives you a completely random number. And then I'm taking the first 256 bytes of it, doing an MD5 sum, so the result's pretty darn random, interpreting that as a number, taking it modulo the number of contestants who got it right, which is 29 here, and let's see what we get. The random number, and boom, number 8. The completely random number 8 is Bork Sniffer. Ooh. My best guess is an industrial shredder crumpling and dismembering cans and sad old electronics. Awesome answer, and congratulations, Bork Sniffer. Well, I'll get an email out to you, get your shirt size, and we will get you a Hackaday podcast t-shirt. And for everyone else, you can listen in next week. We'll have another sound for you to guess. Baloney 9000. That's a good name. This week, I'd like to start off with one that is much deeper than it sounds at first glance/listen. VHS Decode Project Could Help Archival Efforts by Oy Vinden, and this is really interesting. It is a project to digitize old VHS, but also like every other kind of videotape, including SVHS, U-matic, PAL, NTSC, etc., etc. I guess it doesn't work for Betamax because the machines are simply different. This starts off with an old project from Chad Page, LD Decode, which was aimed at decoding laser discs, and updates it to work with VHS tapes. And what it does is it taps. You have to actually solder an RF tap into the VHS machine to get the raw analog signal off of the read head and then digitize that. And once you have the raw signal, you can do all of the hard work like color balancing and making sure the lines line up with each other and stuff. All of that you can do in digital. And so you can end up with significantly better looking archival video than you would get off of even the most high-end VCR players, videotape players, whatever those things are called. And the reason for this, as stated by Oyvinden in the README for this project, is that analog video is like reconstructing paper after it's been put through a shredder. And what he means particularly, if you've ever taken a VCR apart, it's got that read head that's on an angle and that spins while the tape is going by it. And there's actually a really great article about old home video recording technology that Al Williams wrote up in 2016. I'll throw a link in the show notes, where he explains that the tape in a VCR would have to go through at such a high speed to get the relevant data rates through that the tape itself would have to be really strong or else it would break. Like, it has to be hauling through there. And the solution then is to encode it as almost vertical but slightly slanting stripes on this wide tape, and then have a spinning read head that kind of spins in the opposite direction to the tape's travel. And that kind of gives you basically that same sort of, higher inches of tape passing by the read head per second without having the tape itself have to be flying through there. And it's very clever, but what it means is that the video is then cut up into these little strips as the read head goes by, and putting them all back together is the trick here. And once you can get this raw signal digitized, doing it in digital means you can, there's funny subtle color shifts that you get if the head isn't spinning at exactly the right speed or if the tape's a little bit stretched. And you can fix all of this stuff in post once you've got it in video. And so you should absolutely have a look at this. It's actually a surprisingly deep dive here, but the results are clearer looking videotape playback than you have ever seen in your life. And it's really quite stunning. Did you click on that video in the thing?
It is quite stunning.
There's all sorts of crazy artifacts going on in the raw playback that just aren't there in the corrected video. Did we actually used to tolerate video that looked like that back in the day?
Oh, wasn't that bad. I mean, some of them were that bad, but we didn't know any better.
We didn't. The price of doing something like this is actually incredibly affordable. It's based on a hacked PCI video capture card and some software that runs with that. So basically you need to solder something into an old VCR, and then you need this $30 capture card, and that's it. Well, almost. The other cost is that the raw signal coming out of the VCR ends up being about 2 to 3 gigabytes per minute of video. So you need a lot of storage for the raw files. And then you need a lot of processing time to convert them into usable video. And right now it looks like they're getting kind of 5 frames per second doing conversion at a best case. So, if you're going to do an hour, count on 6 hours of transcoding time and 200 gigabytes of storage. That's the trade-off, right? Like, everything's digital. Oh crap, it's a lot of data. Other than that, this looks like a really cool project to save some of the old video out there that, as tapes go bad, is absolutely going to get destroyed as the old crappy polyester tape fails on us.
Rust turns to dust. Well, if we may stay in the 90s, my first hack is recreating the sounds of the 90s with a YM3812 synthesizer. And this is by Tyler. Tyler is, well, he already has clearly, as you can see by the photo, created a YM3812 module for a standard synthesizer rack. But the point of this particular post is that he's giving a comprehensive look into these Yamaha chips, which were so prevalent in the 90s in the early sound cards. Because remember, before sound cards and it was terrible, all you had was the little PC speaker. Beep beep beep. This begins a series, and in this first installment, Tyler does a lot of explaining about FM synthesis and how these chips were able to create so many types of notes and noise with just 9 channels. And then in the future, he's going to show how he created the YM3812 module, although it's already available. The PCB and the code is available already.
Yeah, I have to admit, I totally love this one. The YM3812 was in the Sound Blaster. This was the OPL2. It's a very rudimentary FM synthesis chip. It's got 2 operators per voice, but it's got a bunch of voices, and people managed to squeeze good sounding, but like really computery sounding sounds out of it back in the day. And I think that's part of its charm. But I will be watching this project and this guy's YouTube channel with bated breath.
We've watched your career with great interest. He's undersubscribed, woefully undersubscribed.
Woefully undersubscribed. He's got some awesome looking synth module designs here. All right. There. He's now subscribed +1.
I was 222.
I'm 223. My next hack is ESP32 projects from Northwestern University's Embedded Electronics class. And this is not a 2-fer, this is a 5-fer. This is 5 awesome final projects in one write-up. And each one of them, the students have submitted a Hackaday IO page with all of the details. So you should go check them all out. All these projects use the ESP32. A good number of them use the ESP32 camera module, which is, I've found them really hard to work with. So my hat is off to all of these students here who managed to pull off a final project with it. I guess I should just start talking about the projects. The first of them, Smart Scale, combines a scale with an ESP32 cam and some simple image recognition to tell what you've put on the scale. And then it says, oh, you've got 100 grams of apple, that has this nutritional value. And then you put a banana on it and it says, oh, that's a 67 gram banana, that has this many calories and that much whatever. It's a really cute application, but mostly it's making good use of the ESP32 cam, and it's kind of, it runs an ESP32, so it's got a lot of juice for some things, but that's comparatively little for image recognition. It's kind of just enough to tell some foods apart from each other, and so I love that they're doing that with this. It really pushes it to its limit and does something useful with it at the same time. There's a face tracking sentry gun, dummy smart sentry, which is pretty cool. It's a 3D printed sentry turret. That's kind of fun. But this one uses 5 of the ESP32 cam boards. And that's what's neat about these things is they're so cheap. They're like $5, $6 each. You can buy 5 of them and it's not going to break the bank. They combine the images from all of them to see when a person walks into like a 180-degree field of view. And then there's one of them that's mounted on the turret that actually points at you. So they've got kind of wide cameras looking out for any person and then a targeting camera. And I think that's a really sweet approach and just makes use of the fact that these things are so cheap and you can use however many of them you want. One of the other camera ones is the Polterchime smart doorbell. It's got a passive IR sensor so it can tell when you come into the frame, and then it uses one of the ESP32 cams to see who it is, and it rings a doorbell when you walk up. It's a smart doorbell. You don't have to press the button yourself because you're too lazy for that, apparently. I don't know. The other 2 just use the ESP32 for Wi-Fi and calculation, which seems totally reasonable to me. One of them is the Mimic robot arm, which actually uses EMG sensors on a person's arm to control a robot arm. And that's really cool. The transmission of the signals between, of course, is wireless because ESP32. This is actually a very detailed, difficult, and complicated project because it does all the muscle frequency detection stuff to figure out which muscle's firing and then drives this, pretty sweet looking 3D printed robot arm out of it. Like, that must have been a super fun project to design. And last up, Bright Bulb is it's an IoT light bulb, and it's got an ESP32 in it and a light. It's completely open source. You can do everything yourself, and that's kind of the point here. They also wrote a nice web server for it, and so it's got all of the software side stuff nicely handled. It's worth noting that all 5 of these projects were completed within the same 10-week period by their teams of university students. So when you're thinking about these, you also have to realize that they had to think up a project that they could pull off in 10 weeks and actually pull it off. So they're all the more impressive for that, in my opinion.
For my next hack, I chose Osprey keyboard lets the NRF 52840 spread its wings. Now, this is interesting because it's a bare implementation of the NRF 52840 chip, and if we can just get right into it, eBastler, as I say, used and abused Nordic sample schematic number 4, which uses both of the DC to DC converter stages of the chip. Now this is cool because stage 1 converts the battery voltage to 3.3 volts for the I/O, and then the second stage takes that 3.3 volts and converts it to 1.8 volts for the core. But also, I mean, it's just a beautiful keyboard. I applaud eBastler's reason for getting into it, which is wanting to be a better touch typer, or to wanting to be a touch typist at all. As they figured out, to be a true touch typist, you have to make some shifts, like typing C with your middle finger instead of your index finger, which I believe a lot of people do on a regular keyboard.
Yeah, that's hotly debated in the comments about whether typing C with this finger or that finger is super relevant. People out there should know this is a staggered ortholinear?
It is column staggered.
In that sense, of course, you kind of do have to type the key that's underneath your finger. None of this like slanty, funny, squished in the middle keys.
If you don't, you're gonna have a bad time.
You have to give in to the keyboard on this one.
That's the truth.
It's a totally sweet design. I guess that's part of forcing you to learn to touch type, right? Is that none of the keys have any labels on them.
Well, yeah, if you're running in hard mode.
That is definitely in hard mode. I mean, I think I don't look down much when I type, but I've never tried typing on a keyboard like that.
But when you need that one modifier or something and you're not quite sure where it is, and you look.
It's all right to have it printed on there, which one's caret and which one's ampersand. I guess I use ampersand enough. Which one's percent and which one's caret? That one always gets me.
It also supports a thumbstick and a trackpad, although they're not implemented here.
Ooh.
I think that's pretty cool.
And just in terms of the custom designed PCB here, it is very sweet and very nice looking.
Yes.
Good job, man. Sweet design.
Sweet board design. Wah, wah, wah. Sorry.
That's awesome. My last hack this week is push ESP32 over-the-air updates from GitHub. And this is a project that I think will be useful to a number of you out there. Justin Hammond put this one out. And basically what it does is it has code on the ESP32 that scans a GitHub repository and looks for updated firmware for itself, flashes itself with this new firmware, and that basically will keep all of your little embedded /IoT /home automation /whatever devices all up to date all the time. And it's a sweet and simple solution for that. And if you're using GitHub for your code anyway, I think it's probably a really good one. His library is called ESPGHOTA, so GitHub OTA. Definitely worth having a look at. I'm always scared about what happens if I push out bad code and it bricks them or something like that. I assume there's a smart way to kind of stage things in one branch and then, only have your devices pull on the main branch. That would probably work for that. He had to overcome a bunch of challenges here, including GitHub sends a lot of JSON data back to you. Especially if you have a private repository, you need to have a GitHub API token. You need to trade this with GitHub, and then it gives you all this JSON version stuff back. Having an ESP do all the JSON parsing and stuff was non-trivial, but he has that all handled. It's taken care of by the library. And so if you're an end user, it actually looks really easy to incorporate this into your code. You just kind of tell it to every once in a while check the GitHub, or you can have it only check the GitHub when you press a button or something like that. So you could do simple over-the-air updates just by pressing a button locally on the device. That would probably be the most secure / least open to spoofing way to do it. I guess on a security note, a lot of people chimed in the comments saying things like, is this covered by TLS? Yes, it is. One possible trip up that Justin mentions here is that if you keep your Wi-Fi credentials in the firmware that you're sending over the OTA, you really want to make sure that that's in a private repository, or maybe just store your Wi-Fi credentials somewhere else, like inside the non-volatile storage on the ESP32 itself, and not ever in the public repository. Otherwise, everyone else can log onto your Wi-Fi network. So there's some things you'll need to think about for this in terms of safety of deploying it because it uses public GitHub. But I think all in all, it's a really neat idea. And it's actually such a neat idea that in the comments, it's already inspired Turf PTA-X to create a MicroPython library that's equivalent to this. So GitHub OTA is in C and written for the standard C development SDK. If you're a MicroPython user, that doesn't necessarily help you. And then a couple days after this is written, he's like nerd snipe Turf PTA-X into starting to write his own thing called MuGit to run on MicroPython. And so far he's got it so that it can pull your code down automatically from that. And I'd keep my eye on that if you're more of the MicroPython flavored user.
For my last hack, I chose There's Nothing Square About This Rectangular Guitar. This is the, for all we know, latest build from Yuri Tukman, who it seems can build pretty much anything. To be fair, this started as a kit, so Yuri was asked to compete in the Great Guitar Build-Off competition, which what a cool honor that must be. And everyone was sent a kit with all the wooden parts basically as blank as you can get, which would be a big square. The headstock was square, the body, big square. Yuri looked at that and thought, yes, let's keep that. And basically created this guitar that looks like a Les Paul rising out of a pool of guitar material. Yuri machined square brass knobs for the volume and tone pots, and also made a really cool pickguard out of the supplied pickguard material. I thought it was maybe stenciled on or something, but it is carved and then filled in and then wiped. But yeah, it's a lovely pickguard up close. And then finally, he took it on a train to a luthier and had it checked out, and the luthier said, yes, you have built a guitar, and it sounds great for being a square guitar. Now, we all, well, maybe we don't all know, but some of us know that Bo Diddley played a square guitar, but it was more ergonomic than this. I really like the way this looks, but it would be pretty hard for someone my size to play, especially, I think. Plus, it would, after a while, depending on what you put your arm, that would really cut into your arm, the hard edge there. Perhaps it's not meant to be played.
This is art. This is not a functional guitar. No, it is a functional guitar. I take that back. This is an art guitar.
Now, the thing that makes it not less polished is that pick holder, and that's only because, gasp, Yuri made a mistake and is covering it up with spent, however many hours machining a custom brass pickguard to slap on top of it. Yeah, I think it's great. It looks great.
It looks interesting. I love the luthier's comment that he takes it to. The first thing he does is he picks it up and he's like, oh, that's heavy. Because, he left all the rest of the square on there.
Yeah.
Like you say, it does look like it's a guitar coming up out of the square, and that's actually pretty cool, some of the way he did that. He actually traced the shape and did it all by hand first with a chisel, so it's kind of scalloped and irregular, and then with a Dremel and kind of sanded it down. So it really does look like it's covered in a sheet or something, or it's pulling up out of a thick syrupy liquid.
It's being vacuformed or something.
Yeah, totally. All right, this week I would like to start off my quick hacks with Kiwi Bushwalker's heads-up display clock is transparent time display. This is actually a deceptively simple hack. It's an angled piece of acrylic and some LEDs underneath. NTP time server, Wi-Fi, all the usual tricks. but it just looks pretty darn good for it. And this is one of these like simple kind of magical effects that you can get for not much effort. Worth your time, haha, to have a look at it. Next up, resurrecting Pong one jumper wire at a time. This is a video by Dave of Dave's Garage. So Pong's like this really old school game that was originally implemented on discrete ICs, discrete logic ICs. And then at some point in time, someone invented a single Pong chip. And that's what Dave is using here. He's taking the Pong chip and turning it into a Pong game, which is kind of its intended purpose. Still, it's a neat look at how the kind of primitive one IC home video games used to work. And last up, Jonas de Graaf, a VM in an AI. Again, the world has gone AI crazy with this whole chat GPT thing. One of the tricks you can pull off is to tell it to think it's a Linux command line, and then you can start typing in. What's funny is that it emulates a Linux command line well enough to tell you that it's got files and let you read them and all of this stuff. Of course, none of it is real, and it doesn't understand any of it. It just knows that it has files, and if a computer had files, it would do this with them if you did that. But it's crazy. The illusion eventually falls down when you try to get it to do more complicated things. But until then, it's pretty amazing to be in a hallucinated version of a computer running inside another computer.
For my first quick hack, I chose Nostalgic 30-in-1 Electronics Badge for DEF CON 30. This comes courtesy of Hamster and the DC Zia crew, who made this 30-in-1 badge, get it, for DEF CON 30. Now, we all remember those X-in-1 project thingies with the springs, and you build everything from a doorbell to a radio by connecting things with springs, which someone in the comments has a good lead for buying a 25-pack of those springs if you want to make your own kit like that, which I thought was pretty cool.
Ooh.
Yeah.
Yeah.
But this also came in kit form, as in assembling the badge itself you get to do before you work the kit itself. So that's pretty cool as well. And then next up, Jeffrey Stevenson and his Clean Slate is a vintage amplifier-inspired PC. Wow, is this thing beautiful. And oh man, are there build pictures galore. So this is a mini PC build, and the motherboard is in that platform, and all the other parts are in those custom-built boxes. And then Jeffrey used scrap wood to build those fins, and oh, it's just look at it, because it's beautiful. It built all the boxes, made custom panels for the I/O plate. If you keep going far enough, if you go one past where it looks like the build log ends, you'll run into another PC build that looks like a Art Deco skyscraper, also made by Jeffrey Stevenson. And lastly, but not leastly, Manuel Tassone's retro alarm clock with Nixies is thoroughly modern inside. Man, speaking of gorgeous, there's no slamming the snooze button on this. You wouldn't want to do that, because you might get a couple Nixie shards in your finger for one thing. But boy, this thing is beautiful as well. And I love the choice of yellow with the black. I don't know why. It's just perfect. But it's interesting that Manuel used a transistor array for each Nixie tube instead of a resistor, and that's because this allows for linear control of the brightness, which ought to keep the light constant even as they age, which they're already aged, aren't they? Are people making new Nixie tubes?
No.
Are they all new old stock? I thought they were all new old stock. But I mean, shelf life versus life.
All right, that brings us to the Can't Miss articles. These are long-form pieces written by our awesome Hackaday writing staff. And this week I had to pick Chris Lott's The Story Behind the TV Guardian Curse Catcher. And that is because a couple weeks ago we saw these boxes on YouTube, showing up everywhere, actually. First, we saw a teardown by Technology Connections, and then Ben Eater did a reverse engineering of one of these things. Prolific Twitterer Foon had one, actually a whole series of them. These are devices that you would plug into your TV and it would look through the closed captioning and change dirty words into sanitized versions of the dirty words so that nobody watching closed caption TV shows would get their sensitivities offended. And it seems like an absurd device. And the only thing that's more absurd is that Chris says, "You're not going to believe this, but I was lead engineer for that product. Can I write an op-ed about it?" And I'm like, yeah, go for it. And you may recall that Chris has written a couple articles a while back on closed captioning for TV. And actually, they're both really interesting, and you should give them a look. One is on the analog side of how the closed captioning system worked and how it evolved and what kind of strange chips were out there. And the other one was on what happened to closed captioning after TV made the digital transition. They're both really great reads. And I guess I should have put two and two together, that a man with so much closed captioning experience must have done something in his career with it. But to imagine that he was chief engineer on the TV Guardian is pretty crazy. Anyway, what's really fun is if you were following these other videos, and we all were, and I'm sure I talked about them on the podcast, you get the inside scoop here. And that is that basically an inventor came to them with this, kind of a rough prototype of it, and it was their job to commercialize it and make it into an affordable and mass-producible device. And so it goes through all of their revisions of it and what they had to do to make it work. The best story of all, though, is that at one point, the factory that was programming the EEPROMs that contained all the bad words in them was having some trouble, and Chris was sent over there to troubleshoot it. And they'd been doing some things in the wrong order. And when he got the technician to do it correctly, she finally looks at him and says, "It's none of my business, but there's some really bad words here in your hex file." And poor Chris had to explain to her what the device did. And then after that, they actually scrambled the text. They randomized the memory locations a little bit, just so that if anyone was looking through the ROM dumps, they wouldn't have to suffer through all of these curses. Which makes it even funnier because when Ben Eater reverse engineers the thing, he dumps the EEPROM, and he apparently had a machine that was put out before they did this address randomization trick, because in his, you can read out the dirty words in all of their entirety. Pretty hilarious. Anyway, this is a weird niche device, and it shouldn't surprise you that somebody had to engineer this thing. What's entirely surprising is that our own Chris Lott was the man behind the TV Guardian. Cool story. You absolutely have to read it, at least for the serendipity.
For my long-form article this week, I chose Al Williams's Ask Hackaday, Will Your 2030 Car Have AM Radio? Well, personally, I would say yes, mine will. Whatever car I'm driving in 2030 will have some kind of AM radio, one way or another, whether it's one of my transistors in the passenger seat or not, or if it's actually hooked up to the sound system. Because, why? Wait for it.
I'm waiting.
It's the best way to take in a baseball game.
Fair enough.
That's my reason.
That's legit. I was gonna ask if there's any programming left on AM, and the answer is baseball.
Yes. The impetus of this article is that U.S. Senator Edward J. Markey started a letter-writing campaign to the Big Three, and, well, probably more than the Big Three, urging them to retain the AM radio in future vehicles. Why would they phase them out other than, well, it's AM radio and, in theory, was supposed to have been supplanted by FM radio Even its inventor thought that supporting both AM and FM was a stopgap measure, quote, until FM took over, which I didn't realize. I thought that was interesting.
And this was back in 1930 what?
Yeah.
Something like that.
Let's see. Earlier, electric vehicles, because everybody wants an electric vehicle. That's sarcasm right there, in case you didn't tell. Have been known to cause interference with AM radios. And while you don't really want that, probably, can't these things be shielded? Like, does it cost that much for copper tape or to shield it?
Yeah, right? How much cost cutting is going on when you're taking the AM radio, which has to be like, how many parts is that? It's probably one chip. I guess you have to accommodate that bulky, funny ferrite antenna, right?
Yeah.
Even these days? What is that, $1 in parts? $2 in parts? And that's what's, yeah.
I believe the highway emergency broadcasts are only on AM.
Yeah, that's something that I guess could be changed though, right?
Yeah.
Here in Europe, I don't think we even have AM on the radio at all to like even lose it. And here the FM like analog broadcasts are losing out to digital audio broadcast, which is pretty much all the new cars come with that. Our car is just old enough to have an old analog FM receiver in it. And, you know, if I get to complain about FM, it's that it has weird multipathing problems. And so if you pull up to something that reflects radio signals, like a stoplight pole or, you know, alongside of a truck, you can get this weird doubling of the signal. You get the direct signal and then the reflected signal off of whatever the middle thing is. I mean, I guess I listen to kind of a weak station. So maybe I would appreciate having AM if I could, but digital audio broadcast is so much better than either of them. Al waxes nostalgic about the range of AM radio, and that is with a really big broadcaster, you could get it to skip up into the atmosphere and over, and so you can hear it over a much wider area because it's a lower frequency. And so, you know,
Until you go under a bridge.
on summer nights, you can listen to baseball games, and that's nostalgic, right? Yeah.
Yeah.
So I hear you. I hear you for the nostalgia factor. Like, people in the comments are saying that there's only, you know, kind of blatant politics, religion, and foreign language programming going on AM, which, you know, I'm in favor of foreign language programming. If they get rid of AM radios, will they start broadcasting baseball on FM?
But it won't sound the same.
All right. Well, that wraps it up for this week's Hackaday podcast. Thanks for listening. For links and comments, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, drop us a line, tips@hackaday.com. And until next week,
Keep on hacking.
sharpening his cheese slicer. What kind of cheese is he slicing that it can dull a metal cheese slicer?
Sharp cheddar. Are you ready?
Yeah, go.
Sorry, the cat is alive and in the microphone. Trying to make a podcast here.
This is episode 9. Boom. But it happened. And now it's done.